So what you see on the screen has an absolute value, but it's not an equation because right here is not an equal sign. It's an inequality, a less than equal to sign, right? And so this is not an absolute value equation. It's an absolute value inequality, okay? We solve it very similar to the way we would solve an absolute value equation with some small differences. The first thing I'm going to do is I'm going to add 4 on both sides. My goal here is to get the absolute value by itself on the left side of the inequality. And so I've got 5, absolute value of 3x plus 7 is less than or equal to 15. And then I'm going to divide by 5 on both sides. And so I have absolute value of 3x plus 7 is less than or equal to 15 divided by 5 is 3. Now you're in the same position you were in the equation. You have the absolute value by itself on the left side. But what do I do to get rid of the absolute value bars? Split it into 2 problems, right? Now the first problem I write will be just like I see it. 3x plus 7 is less than or equal to 3. The second equation I write, 3x plus 7, I need to flip the inequality. So the inequality will no longer be less than, it'll be what? Greater than or equal to. And then I change the sign of the number to -3. And now that I've got it set up properly, all I've got to do is solve each one of these individual inequalities. So I'm going to subtract 7 from both sides, and I have 3x is less than or equal to -4. And then I'll divide by 3 on both sides, and so x is less than or equal to -4 over 3. Now -4 over 3 is a repeating decimal, so I'm going to leave it as a fraction. Now let's come over here to the right. I'm also going to subtract 7 on both sides here. And so I have 3x is greater than or equal to -10. Then I'll divide by 3 on both sides. And so I've got x is greater than or equal to -10 over 3. -10 over 3 is also a repeating decimal. So I'm going to leave it as a fraction. Okay? Now those are my 2 answers. But when you deal with inequalities, you don't stop once you have the answer. Now I need to put those 2 answers on the number line. So you can see my 2 answers, and what I'm going to do is I'm going to draw a number line. Okay? So here is a decent number line. Now, real quick, tell me what an approximation of -4 over 3 is. The number -4 over 3 is approximately what as a decimal? -1.3 repeating. And -10 over 3 is approximately what? -3.3 repeating. Is that right? Yep. And so those are the numbers I'm putting on the number line, right? And so I'm going to mark my number line in the center with 0. Okay? And then I'm going to go to the left. Here's -1. Here's -2. Here's -3, and here's -4. Now you're trying to get each of those lines the same distance apart. I didn't do a very good job of that. Now, at -1.3 repeating, okay, now this is -1, this is -2, -3, and -4. At -1.3 repeating, I'm going to have a closed circle. Okay, now let's talk about why my circle is closed. The reason it's closed is because my inequality is what? Equal to. So when you have less than, but you also have equal to. When you have equal to, then it's a closed circle. Now if I look at this inequality, which way is this pointing? To the left. So I'm going to shade to the left. Now I'm not going to do my final shading until I can see where the other one's going. The other one's at -3.3 repeating. And so I'm going to go to -3.3 repeating and also put a closed circle. And if I look at this inequality, it's shaded to the right. So they're shading towards each other, aren't they? And so what I'm going to do is I'm going to take my pencil and I'm going to shade from one point to the next point. Okay? And what I'm going to do also is I'm going to erase the arrows on my shading because it doesn't go left and right forever. It stops. Okay? Now, generally, you also like to write what the domain of your inequality is. The domain means it starts here and it ends here. In this case, it starts at negative 10/3 and it ends at negative 4/3. Now, do you see right here that I have a closed circle? Right here I have a closed circle. Can y'all see that? When you have a closed circle, then on your domain, you get a bracket. If it were an open circle, then I'd get a what? Parentheses. So right here I'm going to put a bracket. And then I have a closed circle here as well. So to the right, I will also get a bracket. And now I've done the whole problem. Notice, I got my two solutions. I graphed it on the number line, shading from one point to the next point. And then I wrote my domain, and this is called interval notation.